Welcome everybody to our talk on Don't Fear the Cloud. We're going to dive into some of the benefits of running Lucidworks Fusion in particular on the cloud, and specifically in GCP. Lucidworks is a partner with GCP, and we leverage them to provide you the best experience for running our software, Lucidworks Fusion, in the cloud. I'm Mike Chesnut. I'm our Senior Director of Cloud Operations at Lucidworks.
And hey folks, my name is Tiffany Lewis. I'm a Cloud Security and Compliance Specialist at Google.
Thank you, Tiffany. I want to talk briefly about why Lucidworks uses GCP. Specifically, we run our software on Google Kubernetes Engine. I'll call it GKE throughout this, and why that's not only a good place to run Fusion, but it's the best place. By using the cloud in general, GCP in particular, we get a lot of benefits. The main one is we get to avoid the undifferentiated heavy lifting that doesn't impact our customer success. What they come to us for is to provide a fantastic search and data discovery experience. Nobody cares if we're good at racking servers and connecting network and power cables to them. So we get ourselves out of that business. We don't have to focus on it. We can focus on what matters to our customers. We also get a new native Kubernetes platform in the form of Google Kubernetes Engine. Google has the most developed Kubernetes offering out there, so we are able to leverage that. We get to benefit from the additional capabilities and functionality that Google provides. We get things like auto scaling and auto upgrades and auto repair. We take advantage of those to make this the best way to run Fusion. And then GCP is also secure by default, and we inherit a lot of security controls from beyond just the table stakes of security, but there's physical security in the facilities, but there's also the fact that data is encrypted by default, and that security is really the first design principle of all of GCP. And Tiffany will dive into some of that a little bit later. I wanted to talk about a few additional reasons why you shouldn't fear the cloud as a customer, either directly of GCP or of Lucidworks, us as a partner of GCP, and why it's better. One thing is that we get to benefit from containers and all of the things that make containers a better way to run software and a better way to operate software, specifically in the cloud, are things that we get to take advantage of by partnering with Google in this and running in Kubernetes. Things like isolated workloads and independent scaling capabilities. The other is that we build on this strong foundation of compliance that GCP provides us. We can meet virtually any compliance requirements by leveraging the starting point that we get from building on top of Google. We're really standing on the shoulders of giants with that. And that also applies to the scale of innovation that GCP provides us. GKE has been out for a while. As I mentioned, it's the most developed of the Kubernetes Engine offerings out there, and we found that our software runs the best on it. And then Google is always adding features. They're always developing and expanding on the capabilities of GKE, and we're able to leverage that. It's if we have an in-house Kubernetes development team without actually having to employ them. We get to, again, stand on the shoulder of giants of the efforts of what GCP and specifically Google Kubernetes Engine are providing to us. And I'd like to hand it over to Tiffany to talk about some of the stuff in more depth around GCP security. Yeah.
Thanks, Mike. Really excited to partner with Lucidworks on this, and thanks everyone for y'all's time. So in the next section, we'll be talking about GCP security, essentially what's given to you out of the box, and some of the controls that customers inherit, as well as the idea of shared responsibility models as it applies to the public cloud. All right, so first thing I have to do is what I call the legal disclaimer, and also addressing the elephant in the room when it comes to Google, right? So Google Cloud's business is, Google Cloud is viewed as an enterprise business by Google, right? This is very different from our consumer model that we have on the ad side. As a result, everything within Google Cloud is your data. Your data is your data, essentially, not Google's. We will never sell your data to any type of third party. We won't use it for advertising or anything like that, right? We also have additional protection mechanisms to ensure that Googlers can never actually see your data, access it, or in any way interact with it in a way that is, not permissible by the end user. We have technical controls against these. We have contractual controls against these. And we also have independent audits that have been validated by third parties to ensure that everything is up to snuff. Now, after that's been addressed, time to look at some of the more fun technical aspects of it, right? So one of the true differentiators of Google Cloud Platform, or GCP, is the way that we approach encryption. We have encryption at rest and in transit by default, right? There isn't anything additional that customers have to do in order to, quote unquote, activate the encryption. And we also take it very seriously because we view security as something that should be available by default to customers. And then you have the ability to customize as you want. But a secure foundation, much like Mike said earlier, is really the best way to start any type of cloud journey. Now, this slide in particular talks about how we view and how we deal with encryption for data at rest, right? So just to kind of walk y'all through the workflow of it. If you were to upload, let's say, a puppy video, right? This is the workflow that it would follow. First is that any type of communication over the internet to Google Cloud is going to require a properly terminated TLS connection. After that, your puppy video is interacting with Google Cloud Platform. The video itself is chunked into several different pieces, right? The amount of pieces varies by the size of the actual content itself, but each of these pieces is then separately wrapped with its own data encryption key, otherwise referred to as a DEC. Each of these DECs is completely unique from another one. The DEC is then wrapped with a key encryption key, otherwise known as a KEK, and then each of these keys are then distributed to Google's global storage infrastructure. That means that you could have a piece residing on a server in one data center, another piece could be residing in another data center. It's a giant mishmash, right? And the beauty of all of this is it's a seamless process. It doesn't have any type of service disruptions, and it doesn't mean that you'd have any increased latency. So it makes it much harder for attackers to ever be able to access your data. The next thing I want to address, just because we are constrained on time, is just high-level security differentiators when it comes to GCP, right? So first is the purpose-built infrastructure. We have end-to-end provenance, essentially chip-to-chiller control of our entire supply chain. After that, we have hardware-based tamper protection. It's called Titan. If you ever want a fun read, highly recommend just Googling Titan key in Google. Can find some fun stuff there as far as what we're doing to prevent man-in-the-middle or vendor-in-the-middle attacks by default. We also have a private encrypted global network. Now, when we talk about security by default, we addressed this a little bit as far as encryption of data at rest, encryption of data in transit. We also have DDoS protection and infrastructure patching, ensuring no downtime. Now, I do want to almost put an asterisk or star by this because it's something that's very fascinating, right? So the feature in particular is called live migration, and it ensures that even if the hardware that your services are running on experiences some type of downtime, let's say if the hardware itself needs to be patched, it ensures that the end users experience no downtime whatsoever. One of the best examples that we have of this is during Spectre and Meltdown a few years back. The hardware that was impacted by that, for those customers using GCP services, they didn't have to reboot their environment or anything like that. Everything was a smooth, seamless transition for them. Right. Next is real transparency. So we are the first public cloud provider to offer something called access transparency, which essentially allows you to see interactions that the cloud service provider, in this case Google, has with your environment. So if you were to issue a support request, you can see who on the Google side is addressing it and what is being done. These logs are immutable, and you can use them for your own auditing purpose. And the final thing here is proprietary controls and expertise. When we talk about Google Cloud, it can include Gmail phishing and email protection, VPC service controls, which allow you to draw sort of a level 7 or layer 7 perimeter around or within your environment, a cloud security command center, a holistic pane of glass to view your entire environment from a security perspective, or user protection services. All of these are great technical features that we have available on the platform. Now, I would be remiss if I didn't address the shared responsibility model, right? So anytime we talk about a public cloud, there's the idea that the cloud provider assumes a portion of the responsibility and so does the customer. The amount of responsibility varies depending on the service used, but it is something that needed to be addressed here, right? And that I always like to remind customers of. Now, this is especially important when we talk about it in scope of compliance, right? Much like Mike mentioned earlier, there's a lot of secure foundational controls available within GCP. However, depending what type of compliance framework you have to meet, there's still things on your end that you'll have to do in order to configure your environment to meet those regulations. As you can see, Google Cloud is devoted to meeting regulated customers where they are at and continuously expanding the amount of both technical services that we have available, as well as guidance around meeting various compliance offerings. All right, next is container security. So in this section, we'll kind of give an overview around container security and some of the inherent benefits of using GCP. All right, so first is just kind of a refresher around what are containers, right? So forgive me if I babble on here a little bit. I was a history major at one point. So when we look at the continuum of tech development, we have bare metal, in which customers are responsible for the entire stack: hardware, OS, app code, dependencies, all that jazz. The next iteration brought us VMs, in which, you know, hardware maintenance was essentially taken out, but then you still had to worry about maintaining things like the OS, the dependencies, and the application code. Containers function as sort of like that next level or that next layer of abstraction, right? Think about it as essentially software on top of software. So that way you don't have to worry about, you know, sort of the VM or OS maintenance like you would in the VM model. At the end of the day, it's a pretty interesting model to go to, and mainly because it has very unique security advantages and implications. The first of which is that containers are short-lived and frequently redeployed, which means that you can constantly be patching, right? Because there's ephemeral, if there's an update or something that you need to do, you would just spin up a new container, right? Containers are also intentionally immutable, and also good security defaults are one-line changes, right? Settings should be secure, configuration should be easy for containers. All right. So what is container security? It can really be broken up into 3 separate categories. The first is infrastructure security. And you can think about this essentially as, is my infrastructure secure for actually developing containers, right? So things that you may think about when it comes to infrastructure security are things like privilege escalations and credential compromise. Otherwise, how can I use native GCP functionality like IAM, audit logging and networking with containers? The second thing to think about is software supply chain, which is essentially, is my container image secure to build and deploy, right? So some of the questions that may come to mind is, how can I make sure that my container images are actually vulnerability free? And the third topic area is runtime security. Essentially, is my container actually secure to run, right? What happens once the container is actually deployed? How can I identify if it's acting maliciously in production? What can I do to isolate and protect my workloads, right? And how can I scale securely? When it comes to Google's overall container philosophy, which is what you get with GKE, right? We believe in prioritizing security by default. This could include things like auto node upgrades, which ensure that you have the latest and greatest version of Kubernetes, right? That have the latest security updates. Integrating the best of Google Cloud Security Platform. So things like IAM, logging, encryption by default, all of those things. And finally, taking advantage of our strong security culture. Google actively invests money into continuously expanding our security team from a personnel perspective, as well as research, ensuring that we're always on the bleeding and cutting edge of what's next. So these are a few of the features and capabilities that are available on GKE. We already talked about node auto upgrade. You also have things like binary authorization that allow for verification of provenance. And for runtime security, we have a lot of really great partners that we work with, as well as local tooling like Cloud SCC. Now, before we end this, I wanted to leave y'all with some fun tidbits, right? The future of security. The first are confidential VMs. So we talked about how Google allows and supports for default encryption at rest and default encryption in transit. The next step is essentially while encryption in memory or encryption while processing, right? And that's what confidential VMs represent. It's currently in beta for VMs, and expected support for containers is on the roadmap, right? But essentially, this allows highly performant inline encryption. And one of the key differentiators for Google when it comes to confidential VMs, right, is it's going to be an easy and seamless process where you essentially check a box if you want to have confidential VMs. This ensures that even the hardware that the VM's running on has no insight into what the VM is doing whatsoever. And it also scales beautifully, so you don't have to refactor your application or have any type of arbitrary limits when it comes to the VMs themselves. Exciting times. And the last thing I wanted to bring up are assured workloads. Our assured workloads are our answers for customers who have to deal with things like FedRAMP moderate, and just FedRAMP in general, right? The idea is that it's able to have restrictions on personnel, on data location, as well as services used, ensuring that they're able to actually meet customers where they're at in an easy way, so you don't have to do a lot of weird customization. And they also come with separate terms and support. That way you can meet whatever compliance requirements that you have. All right. So I think that's about it that we have today. Thanks again so much for y'all's time. We thank Lucidworks for their continuous partnership and are really excited to see what comes next from GKE. If you need to reach out to me or have any questions for the GCP perspective, my contact information is here, as well as Mike's.
Mine is as well. Thank you so much, Tiffany, and thank you everybody for attending.